And here we are with question 9 from the January 2007 Core 2 paper. And kicking off, we've got to solve that 3 log to the base a of x equals log to the base a of 8. And this should be a familiar type of thing, and what you're aiming to do, we've got logs and logs, but what we need is log to the base a of something here equals log to the base a of something on the other side. Right hand side already is a log, so that's just an 8, and you've got to use a law of logs to express that as log to the base a of a bracket. But once you've got a log on this side equals a log on the other side, then this bracket has to equal that bracket, and once you're there you should have no problem finding out what x is. And that's part A. Part B, we've got to show that. So we need a start point and an end point. If we're showing that something equals something else, we might as well start with this and end with that. So once again, we've got a combination of logs here. It's going to be laws of logs. If you can express this thing here as log to the base a of a bracket, and then express the other one, well, the other one is just a log of another bracket to the base a, and then it's a log minus a log, and you should be able to write that as a single log to the base a of some calculation, which convincingly you have to show equals log to the base a of 27 for part B. In part C, we've now got a graph with equation this, and the point 3p lies on that curve, and we've got to say that show what p is. So p is the y coordinate of this point, the x coordinate is p, is 3, so we've got to show that when x equals 3 on this curve here, the y coordinate equals that. In other words, we have to substitute in x equals 3 into here, so that x there is going to be a 3, and it's essentially the same question as we had here. Here we had 3 log to the base a of 6 minus log to the base a of 8 to get to that. Now we've got the same thing, except it's a 3 and not a 6, and instead of getting 27 we've got to get that answer there, but the same strategy works. So hopefully C1's alright, and then finally we've got the point Q, 6Q, also lies on that, and we've got to get the gradient of the line PQ for 4 marks. So to find the coordinates of P, we know the coordinates of P, because P, from this thing here, we know that P is the point 3 log to the base 10 of 27 over 8, and Q is the point 6 something, and to find that something we need to take x equals 6 in that, but we don't need to do all that work again, because look, this line here was that with x equals 6, so in part B we substituted 6 into that, so we know that that is the y coordinate of Q. So we've got the coordinates of P and Q, and we want to get the gradient of line PQ to equal log to the base 10 of Q. So you've got 2 points whose coordinates you know, and you need to get the gradient, which is the difference in y over the difference in x, which you should know from Core 1. If you don't, then shame on you. So it's going to be something minus something over something minus something. The x's you know, so the difference in x will be 6 minus 3 if you do bigger minus smaller, and the difference in y will be this y here minus that y there, which will be a log minus another log. So we've got an easy term on the bottom. You've got a log minus a log on the top. So one law of logs will enable you to say that that is log to the base 10 on the top of a single thing. Log minus a log, use your law of logs for that. And on the bottom, 6 minus 3 is 3. So you're going to have a log divided by 3, which is a third of a log, because there's another law of logs you're going to need. A third times a log can be expressed as a single log. You've got to remember the law of logs that lets you go from a number times a log to log of a power. So, using that law of logs, you should be able to get log of a single thing to a particular power, and the question says that that should be log to the base 10 of 2. So that's the framework of what you hope to do. Coordinates of P and Q, find the gradient, use laws of logs to simplify it to what they say. Okay? Yes. Nice.